All right, in this problem we have three objects sliding to the left and slowing down. This is a force diagram showing force of gravity pulling down on these objects and an equally sized normal force pushing up. They're the only two vertical forces and nothing's accelerating vertically, so those forces are balanced. There's a backwards force of friction that's slowing these riders and the motorcycle down as they skid across the wet surface. There's no forward force, there's nothing pushing them forward, just that backwards force of friction slowing them down. Vertically, we're not accelerating, so the acceleration's zero, so the sum of the forces is zero, so the normal force equals mg. Horizontally, we are accelerating here. And there is a force of friction in the negative direction, so I put that as my sum of my forces, and all of that is divided by the mass of anything here. Doesn't matter if I make my system the motorcycle, doesn't matter if I make my system the driver or the girlfriend or whatever. So in this case, I've got force of friction kinetic becomes mu kinetic times normal force. That's always true. And then that simplifies to mu kinetic times mg, because I already established that in this case that the normal force equals mg, and the masses cancel out. That's true for the motorcycle, for the girlfriend, and the boyfriend here. It doesn't matter about their mass, which is why that in that video the motorcycle slides right next to the riders. They all accelerate with this negative mu g value. That even though the motorcycle would have a way bigger normal force and a way bigger force of friction, it also has more mass and is more difficult to accelerate. The girlfriend's the smallest thing here, and she has the smallest force of friction, the smallest normal force, but she is the easiest to accelerate. That mass cancels out.